Oh, son of a nutcracker. So I wanted to show you, I need to build a well, it's not a hex head, eh? It's an 8-sided head. Okay, I need to build an 8-sided head, or I guess socket, or what, I don't know what you would call it. Anyways, to go in here so that I can undo this cartridge from, or sorry, undo this, I don't know what it's called, thing, from the cartridge itself. Anyways, so that's what I'm building here today. We're going to make this into a big hex nut so that I can then use it on my suspension cap to pull off the suspension cap. Now I could go buy one, but heck, that's no fun. So I've got, let me back up a bit here. So I've got on my mill, I've mounted the rotary table with 4-jaw chuck on there. And then I have a hunk of aluminum there that I'll be cutting the hex nut. So the first step is to center this piece of aluminum onto the 4-jaw chuck. And I'll tell you my trick for doing that, I picked it up off of a guy from YouTube. It's pretty straightforward. I only do one revolution of, I got the dial indicator here attached. I do one revolution of the whole thing, and I note on the dial indicator where the minimum and maximum are. And then once I know the minimum and maximum, I then zero the dial indicator to halfway between minimum and maximum. Then all I have to do, so that's probably one end of the minimum maximum, and then the other one's around, it's coming around here. And then, maybe I should focus that. Yeah, there we go. And then the other end's coming around here. And there's the other end coming up to it right about now. Okay, so I just set my 0 to halfway in between. I'm going to approximate that. So my 0 is halfway between. Now all I need to do is I just go to each side and I set it to 0. That's it. And then you might need to make another round, but it's very quick that way, rather than having to go round and around and around and try and get closer. Just find the minimum, maximum, divide it by 2, set your 0 on your DTI to that, and then adjust to 0 there. There you go. So I now have this centered on the 4-jaw chuck. So the piece is centered with the rotary table. Now it's time to get the mill to have the whole rotary table and the piece centered on the mill. And so I do that by using a center finder. And what I do is I find an edge, I find an edge, and then I set my DRO to 0, I find the opposite edge, and I divide that number by 2, and then I set the DRO for that. Then I bring it back to the middle and I do the front and the back. And so that's how I find the center of all that. So it's coming up right now. So I'll show how I just do this centering here. I have the mill's up and running, the center finder is in there. I'm just going to do this axis front to back here. And so what I'm going to do is I will go to the back. And let's see if we can get some focus on that. I'll go to the back, and then I'm going to drop the quill down. And give myself a bit more room. I'll drop the quill down there. Sorry about the handheld, it's just not super easy to see this. Maybe if I do that. And then I just scoot along until, and you'll see it, it'll pop to the side, so it gets very smooth, and then it'll go, whoop. Oh, where are you? Did I miss it? Just a sec here. Oh no, I'm not even there yet. Oh, it popped already. So you see how the center finder just does a little boop like that? That tells me I'm exactly on that side when it pops like that. There you go again. Boop. There it is. So then I go up to my DRO. Come on, you can do this. Focus. There we are. And then I just zero that axis. I do it both in absolute and incremental. Anyways, yeah. So I've got that axis zeroed. Now back to here. I want to bring that quill back up. Let's get some focus there. I'll bring that quill back up, and then we'll go to the front side. If we can get some focus on that. That's not bad. And then I drop the quill back down for the front side. And then we just bring her on. Okay, and we just go until it pops. And boop, like that. So now back to the DRO. It says 2.6972. So all I do is I just divide that by 2 and I set my DRO to that value, and then I'm going to be in the center. That's it. I'm just doing a little facing first on it with the end mill. I didn't want to use the fly cutter. I don't know. See if we can get some nicer focus on that. I kind of like the look of running an end mill with multiple passes. It looks kind of a little bit different for me. And honestly, it doesn't make any difference. This is just a tool using the shop. What the heck, eh? Anyways, there we go. Okay. Here's what we're going to do. I need to make an 8-sided head. The width of that head is 1.4 inches. I could make it a little bit smaller than that, but it's 1.4 inches. I'm going to use a 1/2 inch end mill for that. So, if we were to looking down on the machine, 0, 0 is right in the center of my workpiece. Half of the 1.4 inches is 0.7 of an inch, and then the distance of my mill, or sorry, my end mill is another 0.25 of an inch to the center of the end mill. So what I need to do is I need to set my DRO to 0.7 plus 0.25, which is 0.95 of an inch on the one side, and then I can just make my cut. And then what I do is I spin the DRO, or sorry, I spin the rotary table. So I've got 8 sides, and 360 degrees divided by 8 is 45 degrees. So I just need to set my DRO in one position, one place, or the mill in one position, the DRO, and then I just spin the rotary table every 45 degrees once I finish my cut. That's it. We'll just finish off the last cut. I think what I'm going to do though is I'm going to just shrink in a little tiny bit, because that mill, the side cut that it does, it's just crappy basically. Like we'll get a zoom in, I'll shut off and I'll show you this side cut that it does, and it's just crappy. Let's see, zoom in on this guy. So there's a zoom in and you can see that side cut is just ugly. So we'll probably come back and take just a hair off to clean that up, make it a little bit nicer. Well, why not, eh? Well, I took it down just a little bit, and the edge is improved, but it's not very good. I think I need to get some better M mills. But anyways, that fits quite nicely. It fits the suspension quite nicely, so that's great. So now all I'm going to do is I'm going to flip it over, and then I'll just put some kind of socket head on there so that I can put a wrench on it, and this job will be done. I suppose I could put it on a lathe and skinny it up some. That'll fit on a 4-jaw nicely. Have to think about that one. Not sure. I've decided that I'm going to actually turn this down a bit. Probably about the diameter of the fork itself. Just because there's too much junk on there. So I'm going to turn it down here. I'll flip it over, recenter it, turn down the rest, and then I'll decide what kind of drive I'm going to put on the other side. Whether I'll drill a hole and try to do a square hole to put a 1/2 inch socket wrench in there, or maybe I might do another hex nut, except quite a bit larger of a one, or longer of a one, maybe for a 19mm socket or something. Yeah, fun and games. Well, there's a nice finish on there. Shame about this side of the mill. I need to put some kind of an indent in the middle because there's an adjuster screw, probably a compression adjuster screw that sits proud. So I need to kind of hollow out the center here a little bit. So that's what I'll do next. Okay, here we go. Yeah. So we got the top, we got a little bit of a recess in there to clear for the compression adjuster valve. We've got a shoulder on here. So what I'm going to do is I'm going to pop this into the vise just like that, into the lathe, and I am going to turn all the rest of it down, and then I'm going to decide what the heck I'm going to do to drive this, whether it be a socket screw or 1/2 inch socket drive, or whether I'll put another hex nut thing on this side for a 19mm socket. I decided I'm going to put a 24mm hex head on this thing. So on the lathe, I roughed it down to, I don't know, maybe about 28mm or 29mm. Anyways, larger than the cross diameter of the apex of the hex. Whatever. Anywho, I'm going to do it a little bit differently on the mill this time because I was so dissatisfied with the side cutting of the milling end mill that I have. I'm going to actually cut this a little different on the rotary mill. So stay tuned and let's see what that looks like. So here's what I'm going to do is that I've got the rotary table mounted. Where is this? Vertically, I guess. Vertically, but the axis is horizontal, so I don't know what it is. Anyways, I got it mounted the opposite direction. And so this way, what I'm going to do is I'm going to take off. I'm going to still rotate the rotary table, and I'm just going to use the end mill though to make it, and I'm not going to let the end mill touch this shoulder here to keep the nice finish on the shoulder, and that way I get a much better finish on the actual hex nut side, and I don't let the side of this crappy piece of shit end mill muck up my work. Anyways, that's what I'm going to do now. Okay, here's our machining plan. Our nut that we want to make, a 24mm to fit in there, is 0.950. 95. You know what? Let me redo that one again. Okay, I just finished milling this hex head, so this 24mm hex head. It worked out quite a bit better. I found a Niagara 1/2 inch 2-flute cutter in the drawer, and that seemed to work a lot better. It's not ideal for aluminum. Ideal is 3 foot or 3 flute 45-degree cutter. But this is a heck of a lot better than the cheap Chinese tin ones I was using. I was also using some WD-40 lubricant. So the side cutting is better. It's not awesome, but it is definitely better. I think I might actually do some experimentation with some end mills in another video and look at climb versus conventional and using lubrication or not, and see what the differences in quality are like. Anyways, so that's it. So I'll show it to you next in operation, and then that'll be it for this video. Okay, well, let's take a look at this. So we've got on the top, we've got our 24mm head that we'll use to drive it with. And then on the bottom there is that larger, whatever, 36 millimeter head to fit in the suspension bracket. A little bit of a space there for that compression adjuster. Yeah, so let's give this a shot. Okay, top of the fork, and goes our little tool that we just made, 24 millimeter wrench, and life is easy. Yeah. Oops. Okay, and then you got to drop the thing on the floor. Crying out loud. Anyways, we're all good. I kind of wish the previous person working on the fork used a proper tool, because you know, the top of that thing's kind of bunged up and damaged a little bit, but and out comes our cartridge, we think. Okay, that's going to be a different video, how to get the cartridge out. Well, whatever it is. Oh well. Make sure to subscribe. Thanks for watching. Bye.